Hey guys, so in this video I'm going over lesson 2.1, simplifying under the radical and imaginary numbers. So the first thing is we want to talk about what is a radical, what are the different parts of a radical, and what are we going to do with it. So the different parts. So the first part you get to is the coefficient. The next part you get is the little number right here, which is the index. If you do not see a number in this position, it is always 2. The number underneath the radical is the radicand. And then the actual symbol itself is called the radical sign. So during this, we are going to find the prime factorization of the radicand. The index, which was that small number of the radical, it tells you what size of identical groups can be removed from the radicand. Circle these groups when you do prime factorization. So circle. For each group, or for each circled group, the number or variable will be multiplied by the number in front of the radical. If everything is removed from the radicand, the radical sign will disappear. If the index is not written, meaning you don't see a number in that little small position right here, then it is automatically 2. So let's go over prime factorization. How we're going to do our prime factorization is by the factor tree method. So there's steps there that you can read at your own time. But let's look at 64. What is the smallest number that can go into 64 evenly? 2. So we could do 2 times what is 64 and go from there. Now, if you can go ahead and say, okay, well, there's a bigger number that can go into 64, and it's 4 and 16. That's fine. It does not matter. As long as wherever you start, you keep on branching out until you get to all prime numbers. What do I mean by prime numbers? Meaning you can only divide it and get a whole number by itself in 1. 2 is an example of a prime number. You can only divide 2 by 1 and itself, which is 2, and get a whole number. There is no other number to divide 2 by and get a whole number. So I'm going to do 16 and 4. Neither 16 nor 4 is a prime number, so I'm going to keep going. I know 4 times 4 is 16. I also know 2 times 2 is 4. 2 times 2 is 4. 2 is prime. And then we've got 4, so 2 times 2, 2 is prime. So that would be your prime factorization. Let's look at 84. What times what gives us 84? We'll start with that 12 and 7. There are other combinations. 7 is prime. 12 is not, so I'm going to expand 12. 2 and 6. 2 is prime. 2 and 3. 2 times 3 is 6, and 2 and 3 are prime. So that would be your prime factorization. Now, it gets really easy if the number you are factoring or prime factorization doing is a perfect square. What do I mean by perfect square? I mean, I can take one number, multiply by itself, and get that perfect square. So 1 is 1 times 1. 4 is 2 times 2. And I was looking at that 9, my bad guys. Times 2. 9 is 3 times 3. So it's multiplying by to itself. So another example, so we've got 1, 2, 3, 4, 5, 6 times 6 would be 36. 7 times 7 would be 49. Here we go. 8 times 8 would be 64. 9 times 9 would be 81. 10 times 10 would be 100. And 11 times 11 would be 121. So those are some examples of your perfect squares. Now, for your exponents and for your variables, x times x is x squared. X squared times x squared is x to the 4th. The reason why, and we're going to go over this in this unit, if you're multiplying, you are adding your exponents. That's why this works. So this would be x to the 3rd times x to the 3rd, because you would have 3 plus 3. Next one would be x to the 4th times x to the 4th, so you would have x to the 8th. X to the 5th times x to the 5th would be x to the 10th. All of the perfect squares must be even. So the square root of 25 is read as the square root of 25 because there is no index indicated. So there's a 2. That's where that square word is coming from. So in this case, we've got square root of 25 is 5. Because if you do 5 times 5, gives you 25. So what about 36? Well, the square root of 36 is 6. That means if we go backwards, just to get to 36, not the square root part, just to get back to 36, it would be 6 squared, or 6 times 6, gives us 36. What about our 100? Well, what times itself gives us 100? 10. Now, while we're on this one, could we not also do negative 10 times negative 10 to get positive 100? Yes. So we're going to show this by putting a plus and minus sign in front of our answers. 49. What times itself gives us 49? 7. And it's plus and minus. All right. So with the variables, so we're going to have a to the 3rd times a to the 3rd gives us a to the 6th. That's what that second is talking about. So if we take m to the 8th and square it, we're going to get m to the 16th, because we're going to do m to the 8th times m to the 8th. We're going to add the exponents together. Now, I want to skip that just for a second. If you ever forget those steps, there is another way. So remember that if our index is not indicated, it's a 2. And a squared is the same thing as a times a. Well, this 2 tells us how big our group is that we're going to group together and move out of the house. So I like to say they're going to, 2 of the same kind, get together, get married, and move out of the house. So the A's get together because they're the same and move out of the house. So that becomes a single A on the outside of the radical. So that's just it, reinforcing the definition. So let's do some more. So what if it's not a perfect square? Actually, all of these are. So let's do some more perfect squares. So 4, we've got 2 times 2. Those are prime numbers. So we're going to have the square root, 2 times 2. Index is 2, so we're going to move a group of 2 2's outside. There's nothing left in the radical once we move those 2 out. We have plus and minus. Let's do number 3. Now, I want the negative. I don't want to look at the negative right now. I just want to deal with the square root of 100. So what times what is 100? 10. So we have the square root 10 times 10. Index is 2. So 2 10s get grouped together and move out. So we have plus or minus 10. Now we have that negative. So we have negative times plus and minus 10. Well, negative times a positive. So this means negative times positive 10. This also means negative times negative 10. Well, this negative times 10 is negative 10, and negative times a negative is a positive. So we still have plus or minus 10 as our answer. If there is a negative out front, we don't care about it. It doesn't affect our answer. Again, negative on the outside of the radical sign does not matter. Does not affect anything. Going on. I'm going to do number 6. Now, the trick is when you are dealing with your variables and exponents, if it is even, you can come in here and divide it by your index. Each one we're dividing. So that means on the outside we have a to the 3rd and b to the 5th. Now what if you have both numbers and variables? Well, 9 is 3 times 3, and a is a times a. So that means under the radical, we have 3 times 3 times a times a. And our index is 2, so we're looking for groups of 2 of the same. 3 gets moved out. The a's get moved out. We have plus or minus a 3a. So this is kind of going over what if we have a negative in the exponent. So this also is referencing our solutions or our x-intercepts or our roots or our solutions on our graphs. So our x-intercepts. Well, in this one, our solutions would be negative 2, 0, and 2, 0. In this case, there would only be one solution, and it's at 2, 0. In this case, for now, there is none. But we're about to go over an example or a way that there is still a answer or still a solution. So real numbers. Real numbers are the numbers that there is an end to it. So let's say these are the natural numbers, which is 1, 2, 3, so on and so forth. The whole numbers, which is 0, 1, 2, 3, so on and so forth. The integers, which is negative numbers, 0, 1, 2, so on and so forth. The rational numbers, which is like 2 fourths, negative half. There's an actual end to it, is the rational numbers, but there's still a decimal or a fraction. Irrational numbers is where it's a decimal and it keeps on going forever and ever. Pi, square root of 2, so on and so forth. And then imaginary numbers is going to be where we have a square root and there's a negative sign on the inside. So when we use that negative on the inside, it's going to become I. So these are examples of imaginary numbers. So what is an imaginary number? An imaginary number is what you get when you take the square root of a negative number. An imaginary number contains I to show that the number is imaginary. So anytime you see I equals negative, or square root of negative 1. We know how to take the square root of positive numbers. The square root of 9 equals plus or minus 3. Because 3 times 3 equals 9. And, again, because we have a plus and a minus, negative 3 times negative 3 is also positive 9. But when we try to take the square root of a negative number, like the square root of negative 9, we can't have a real number solution because no real number multiplied by itself, meaning plus times plus or minus times, like plus times plus or negative times negative will never give us a negative number underneath the radical. Will give us a negative number. Now that we can take the square root of negative 1, however, we can find a solution. So what I want you guys to know is that when you do your prime factorization, you can always take that negative 1 out and then deal with the number itself. So 3 and 3. So that means we have negative 1 times 3 times 3. So that negative 1 is going to come outside as I. And the two 3's are grouped together for a single 3. So that means we're outside going to have 3 and I. So we have plus and minus 3i. So let's go over some examples. What if we had the square root of negative 36? Well, I'm going to take out that negative 1 first. So negative 1 times 36 gives me that negative 36. What times what is 36? 6 and 6. So that means we've got the square root. Remembering our index is 2 because it doesn't indicate otherwise. negative 1 times 6 times 6. Negative 1 comes out as I, and the 2 6 comes out as a single 6. So we have plus or minus 6i as our answer. Alright. 3, I've already told you multiple times now, negative on the outside does not matter because we're going to have a plus or minus anyways. So if we just had the square root of negative 81, we're going to take that negative out. We're going to have 9 times 9. So that means we're going to have square root negative 1 times 9 times 9. And we have plus or minus 9i. Now, if you really don't believe me, then you would come in here and do negative times that. Well, negative times a positive is a negative, and negative times a negative is a positive. So you would still end up with a negative 9, or plus or minus 9i. Now, what if there's a number on the outside? So let's just deal with the square root for now. So we've got negative 1, 49, 7 times 7. So we would have plus or minus 7i. Then we're multiplying by 2. So that means we're going to multiply that 7 by 2. So we have plus or minus 14i. And that would be your answer. All right. Make sure you get this down and do